So good day. This is Dave McAllister of Scalyr, and welcome to this edition of Scalyr Insights. Today we're going to talk about what log files can really do for you, how you can drive into logs, and how you can actually use logs to resolve to the root causes of things as quickly as possible. Joining me today is Steve Newman, who's our founder and chair of Scalyr. Scalyr is, I believe, Steve's sixth company that he's been part of here. And most recently, he started one called Rightly, which was acquired by Google and led to Google Docs. Steve started programming when he was 8 years old and has definitely more insights and information on both logging as well as complexity of systems on scale and distributed environments. With that, I'm looking forward to learning a lot from you today, Steve, and welcome to Scalyr Insights.
Thanks, Steve. I'll dive right in. If you learn from your mistakes, then I've had a lot of opportunities for learning over the years, and I'm going to present a little bit of that, a little bit of the result of that here. Just diving into the topic, there's basically two parts to this talk. I'm going to spend the first part of the presentation talking about what to log, what kinds of information to include in your logs, or as I like to think about it, things you can do ahead of time to make your life easier when you're later trying to solve a problem. Setting yourself up so you'll have the information available that you need. And then I'll spend the rest of the time talking through some different scenarios of troubleshooting and problem solving, situations where you might need to rely on your logs, and what some of those scenarios might look like, and again, more details about what you can do up front that will make those things go more smoothly. So diving right in, what to log. Conceptually, it's kind of simple. I like to say you should log any event that you might need to know about. Each one of those logs should have enough details so that you'll be able to narrow down a problem. And it should be in a format that's both readable and parsable, meaning that when you or one of your fellow team members is looking at the logs, that it's scannable by the eye, but also that it's parsable by a machine, so that your tools can really help you manage those logs. So that's very high level and really not very actionable. So let's dive in and start to make some of this practical and useful. So log any event you might need to know about. Well, what does that mean? And there are really two big categories. The first is information to localize problems. So, in modern tech stacks, you're probably running, a large number of services, relying on a bunch of additional services from a cloud provider or other third-party providers. So these are very complicated systems we're all managing, and half the battle in any investigation is just figuring out where the problem is actually coming from, because the symptom that first draws your attention may be several steps removed from the underlying source of the problem. And so localizing problems is always half the battle. And to be able to do that localization, it's very helpful to have logging around the communication between services and systems. So often that will be remote procedure calls or whatever mechanism you're using for your different services to talk to one another. You'll want to log that, ideally at both ends of the communication, the client side and the server side. But if you're only going to do one of those two, you'll want to focus first on logging from the client side, because there may be some situations where a request never makes it to the server, or the server is not able to properly receive and receive the message, and then the server won't generate any log record at all. So if you're only going to log on one side, you want to log on the client side, since that will always be present. If you're running a more monolithic system where there's a lot of functionality bundled into one service or one application, then probably that will have within it different subsystems. They may all be running in one process, but these are still different systems, different pieces of code, maybe implemented by different teams. And again, useful to be able to narrow down a problem into which one of those subsystems it originates in. So again, you'd want to log that communication between systems, even if they're in the same process. And then finally, you may have systems with a lot of internal state where interesting things are happening without any kind of communication. And so again, to have some visibility, to be able to shine a little bit of light into that cavern, logging major events around those subsystems, the amount of resources being used, the amount of information that's accumulated in a queuing system, things like that can be helpful. And the second category of things worth logging are basically unusual events. The classic example of that is an exception or a thrown error report, hopefully with a stack trace. Those are always worth logging. But any kind of an error situation, error code, anything that fails, whether it's with an exception or a stack trace or not, is worth logging. Anywhere, if your system has any kind of circuit breakers, limits, caps, rate limits that kick in, whenever one of those kicks in, and that's worth logging because that's an unusual path. You may then find yourself trying to debug, why was this request not processed? And if the answer was, well, because it hit a rate limit, then you'll really want to have logged that. And more generally, any branch of your code that is not normally expected to trigger. So when you're writing code and you're writing some code to handle some unusual or should never happen circumstance, or should rarely, a circumstance that should only happen rarely, that's worth logging. And finally, large actions. And large might mean that they have something that has a significant business impact or significant impact on some persistent data structure on your database or something. So things like users creating or deleting an account or placing an order, anything that has a little bit of heft and consequence to it. If there's a problem with an action like that, you'll really want to know about it afterward. So those are always worth logging. Okay, and then whatever you log, you want to have details in it. And the kinds of details that are worth thinking about are how did we get here? Later when you're looking at this log message and you see that something happened, you're going to know, why did it happen? What triggered that? And so information about, what other service or system invoked this system, what URL was, if it's a page on your website, which page was it? If this was a service handler, an RPC handler, who invoked that, who sent the request, which IP address or server sent the request, what operation was invoked. And then what pieces of data were being operated on, the record ID, the user ID, whatever parameters to that operation are going to kind of determine what it's working with. That's very helpful to know, both if you want to reproduce a problem or determine who was affected by a problem. And so things like user IDs are particularly important. You might be looking at a log message, realize, oh, wow, this happened. I should talk to that user to sort it out. Or alternately, you may have a user come to you and you want to track down something they're reporting. So either way, it's very, very helpful to have user IDs in your logs. And finally, the kind of the ultimate detail, if it's affordable in this situation, is to log the complete input to an operation. So whatever operation is being invoked, whatever parameters are passed into that. If you can log that complete content, that allows you to exactly reproduce the operation later, which again can be very, very helpful for debugging and troubleshooting. And if that gets to be too noisy, you can apply rate limits. So maybe we log this data at most 1 time per second, and that kind of limits the cost of it, but still gives you a lot of detail when you need to dive in and see exactly what's been going on. And so let's make this a little more concrete, show some examples of different styles of log messages. So here's a singularly unhelpful log message. Unfortunately, also a fairly realistic log message. I've certainly seen things like this in practice. Here we have some low-level language engine or something that's reported that some code tried to access an entry that was out of bounds of an array. Gives you absolutely no information about what array, what code, why, what happened, is it going to happen again. Here's something that's a little better. So it's still array index out of bounds, but now, again, that same probably low-level piece of software that detected the problem has told us the array size and the array index. We still don't really know what's going on. We don't know where in the code or or anything else, but at least we have a few hints. For example, that array size looks reasonable. The index does not look reasonable. So it's a guess that, maybe this piece of data was corrupt somehow. It might give you a hint to narrow down the problem, but it's really not very much information. Now so now imagine that your log message also includes the ID of the user on whose behalf we were operating when we tripped over this, and the identity of the other server that invoked this server that had the error, and a stack trace. So now, and this is all information that can be achievable in practice in your logging code. And now you know exactly where in the code the problem happened. You know the path through the code that got you there. And you have some hint about what data might have been involved, whichever data belongs to this user. And so you'll have much more opportunity now to actually directly investigate the issue. And then, really the gold standard, as I mentioned earlier, is if you can also log the complete input to that file or to this operation. So in this example, we've, actually, so this example is taken from something that's actually happened a few years back within Scalyr. So we have a system that sits at the front of our web server and rewrites every HTML file that we serve to optimize it, reduce the file size by stripping out comments and white space and things like that. And every now and then over the years, we've had an incident where some oddly formatted piece of HTML would crash that optimization code. And these were kind of impossible to reproduce and therefore to debug. So we modified the system so that whenever there was an exception thrown from that piece of code, that it would write the HTML file that it was trying to process to disk. And this was rate limited, where it would only log 1 file per minute, so there was no real risk of that chewing up too much disk space. But it meant that when the occasional unusual problem would occur, we had the exact text that triggered it, and it then became very easy to reproduce that problem and track it down. And finally, the format of the logs. So, classically, a lot of logs come out of some kind of a printf style statement where you have a little template in your source code with a message in it, and some fields get dropped into that. And these tend to be written for human consumption rather than machine consumption. So here's an example, we decompressed a request with content encoding null and came out to this many bytes. So this is, almost an English sentence. It's fairly easy to read, but it's very ad hoc format and be annoying to parse with a machine. You'd have to write a parsing rule that's specific to this exact message, and you'd have to repeat that for each message and each different message format in the log. A more modern trend is to emit JSON logs. So these obviously are very easy for a machine to process, but they're a lot harder to read. It's all full of quotes and colons and things that kind of get in the way, and these sort of artificial field names where a human being knows this is a timestamp without having the word timestamp stuck on it. But we've put it there for machine benefit. So suddenly the whole thing becomes a lot more cluttered. Style I like is a little bit of a compromise between the two, where you include some structuring, but you don't really need to go to full JSON. You can just put unquoted key equal value pairs. And this tends to be kind of robust enough for 99.9% of what you're going to see in a log file. So it's really quite easy to parse with any kind of a decent parsing engine. It's a regular structure, but it's a lot less cluttered than a JSON record. So the style in this example is we have a couple of fixed format fields without any labeling on them. We have a timestamp, a server name, and an initial message. And then whatever additional details are worth extracting are put in this key equal value style. So this is quite easy to read. It's actually the shortest, most compact of the three styles we've had here. And flows pretty well to the eye, but also very easy to process in a machine. And then iterate. Logging, like any other software, is never done. And so if you're trying to investigate an issue and you didn't have the information you needed in the log, or maybe it was possible to track down the problem, but it was quite tedious, that you didn't have information that directly bore on the problem, add more logging or revise your logging. Conversely, if I've mostly talked about things to add, but if you find your logs are getting too large, they're just annoying to read, or it's overloading your log management system, then you can start to take out, see which logs you really don't use in practice and take those out, or put some kind of rate limit or sampling on that. So you want to, just like any other piece of software, you want to iterate over time, and you kind of always get better. And ideally, as you're imposing, turning things off or imposing sampling rules and limiting rules, ideally that should be adjustable on the fly. So for example, you might have some detailed debugging logs that you don't normally need. You'd like to turn them off. But then in the heat of the moment, if you're investigating a problem, it'd be nice to be able to turn those logs back on, maybe just for a short period, and get that extra information. And finally, for this section, just a couple of extra tips. Sometimes you'll have logging that is on code that doesn't normally execute, for example, on an error path. And so it doesn't really, the logging code is there, but it's not generating the output. And then one day something funny happens. Your disk fills up, or a service that you depend on goes down, or something goes wrong. And suddenly every request into your system is throwing a stack trace. And stack traces can be quite large. And suddenly you have a flood of log output, which can actually make it more difficult to, it can overload your logging solution, depending on what you're using, just at that moment when you need it most. And so a good kind of prophylactic measure in advance, if your logging library supports it, is to put rate limiting on all of your error case logs, stack trace logging, just so that, if suddenly things are going wrong and you're hitting 1,000 errors per second, if you only log 50 of those 1,000 stack traces, that's going to be plenty of information to track down the problem. And at the same time, by limiting that, you'll have preserved the health of your of the tools you're going to be using for the investigation. And just one other tip I'll mention is if you're coding, as most of us are today, in a multi-threaded system, a system where a single process may be handling multiple requests at the same time, the log output from those different operations will all get intermingled, and that can make it harder to sort out what was going on. If you include in your log format, if you include a thread identifier, then suddenly it becomes very easy to look at these 50 different messages in a certain time period from a single server and see which ones were part of a single operation and which ones were just mixed in from other operations happening in parallel. So throwing those thread IDs into your logs, especially if you're logging multiple steps in your operations, you have fairly detailed logging. This can make that a lot easier to take advantage of. So that concludes the first portion of the talk, kind of what to log. And now, as we discussed, we'll go through a few different scenarios. And the first that we'll talk about is troubleshooting. And troubleshooting, briefly defined, is any situation where you have a symptom. Your site is down, certain operations are receiving errors, something is slower than it should be, some kind of symptom, and you want to find the root cause so that you can do something about it. So this process might kick off with an automated notification. You had an alerting rule that told you about a problem. One of your users may have reported a problem, or you may have just noticed something yourself. But in any case, you're starting with that symptom, the performance issue or the error message or something like that. And so the first step in an investigation is going to be to find log data that corresponds to that problem. So if some operation is failing, people are seeing errors, you should have logs that report those errors. And in those logs, there will be a status code or an error message or some kind of detail about the error. If it's a performance issue, hopefully you have some logs that record the performance, for example, the elapsed time to process each request into the system. If the problem is an overload, some system has reached its capacity limits, then look for logs that report on the usage of that service. So maybe if you're logging all of the requests to that system, then that shows you how it's being used. Once you've found these logs that correspond to the symptom that you've observed, then you can start to use the detailed information in those logs to break down and work your way toward the root cause of that symptom. Logs will include a lot of, certainly if you've set things up well, will include a lot of information, which server did this operation take place on, which customer or user, or at least IP address invoked it, and so on. And so now you can start to do facet analysis on that and see, are my problems spread across my servers, or are they focused on one single server? Is it affecting all of my users or only a certain user? Maybe if it's only a certain user, then the problem might be something specific to what that user is doing, or it might be specific to the database state of that user. But whatever pattern might jump out in this facet analysis is going to give you a pointer toward the root cause of the issue. And so that'll hopefully get you one step closer to the root cause. It may show you, oh, this service is having problems because it's relying on that other service, which is also having problems. But at least now you're one step closer. You can pivot over to that other service and keep drilling down. So let's run through a quick demo to kind of make this concrete. So here I'm looking at, and this is in Scalyr, but we're looking here at a kind of high-level health dashboard for a collection of web servers. It's just a bunch of basic statistics here, the amount of traffic into the system, how that breaks down into different status codes, and so forth. One of these graphs shows the response time, which is, say, the amount of time it's taking the server to process each request. And we can see some periodic spikes here, which indicate a periodic performance issue on the server. Maybe we've noticed, might imagine we've noticed this ourselves on the dashboard, or it might be that somebody has reported that the things were running slowly for them. So we have a performance problem. We're looking for log data that will measure the performance, because that connects the symptoms to the logs. And so this graph is showing us that we have log data that's reporting the system performance, and it's showing this problem. So let's dive into that. I'm going to bring up a pivot off of the dashboard into a larger version of this graph. And now over here on the left, we're seeing a facet breakdown of all of the different pieces of information in these logs. So we can see things like, which page on the site is being loaded, which server processed the request, and so forth. But before we analyze that, let's take a little bit closer look at the nature of the performance issue. So I'm going to zoom in on this time range around one of the spikes. And then I'm going to go over here to the time field, measuring the elapsed time for these requests, as we're seeing on the graph, and bring up what we call in Scalyr the distribution view. And this shows a histogram of values in the field we selected, which was the time field. So we can see what are kind of the most common amounts of time to take processing a request. And we can see actually the most common values are down here 2, 3, 4, meaning these are requests that took just 2 or 3 milliseconds to process. They were processed very quickly. And a lot of requests are processed in less than 50 milliseconds. And there's another group that takes around 500 milliseconds or so. But there's this long tail way out past 10 seconds. And that might account for the problem we were seeing. So let's zoom in on that. Let's look at just the requests that took at least 5 seconds to process. So I'll click update. We've reanalyzed the logs, focused in just on those slower requests. And now I'm going to flip over to the raw log view. So this is the same data that we had been looking at all along. Those same so all the way back from that dashboard, we were looking at the access logs to the system, but we were looking at kind of high-level visualizations of that. Now we're looking at the raw data, the raw logs. You can see each one of these requests took at least 5 seconds to process, because that's the filter we've applied. And now this facet analysis starts to get more interesting, now that we're looking only at the slow requests. So we can see, for example, that instead of the 8 different pages that were reflected in the overall request log, all of these slow requests are from a single page. We can see still there are a bunch of different servers involved, so this doesn't look like a problem specific to one particular server. A lot of different users are hitting these slow pages. There are a few outliers, and one user in particular who accounts for more than their share, but there were 741 of these slow events matched, and only 110 of them came from that user. So it's not completely specific to that user. But anyway, we might find some avenues for investigation here. But I'm going to show off another avenue we can use to investigate. These particular logs that we're looking at include a request identifier. And this is something that the application is including in its logs that's passed around through the system as a request is processed through different steps and different services. And we've configured something in Scalyr here so that these request IDs are hyperlinked. And so I can just click on that, and it's going to do a search for everywhere that request ID appears through all of my logs from all of my servers. And so I can see that this particular request came into a web server, was passed along to an application server, issued a few database queries, and then this funny message was logged: invalid cache detected. And let's say I'm not familiar with, I'm an engineer working on this system, but I'm not used to that message. And I'm wondering, is this a fluke or did I stumble on something that's happening frequently? So I'm going to select that message, invalid cache detected, and click New Search. So this is going to discard my current search criteria and search again all hosts, all logs for that text. So let's click that. And we can see, wow, this error message is happening a lot. And the timeline here shows me that it's clustered in time it's occurring in bunches every hour or so, which was the same pattern as that performance problem that we were seeing back on the original dashboard. I'll pop back there, and we can see, these spikes are occurring about once every hour. So now we've got a pretty good hint that if we go into the source code and look for that, that invalid cache detected message, we'll have a pretty good idea of the root cause of our performance problem. So, and actually, sorry, one last step before I move on. Now that we'd gotten to this invalid cache detected message that appears to point to the root cause of our problem, I'm going to save this for future reference. I'm actually going to throw it on a dashboard. So I'm going to make a new dashboard called Troubleshooting. And, there's a graph title, so let's call it invalid cache. And we'll create a new dashboard called Troubleshooting. And in a minute, I'll explain exactly why I've done that. But so now we'll move on. And just to wrap up the troubleshooting section, some things you can do in advance to set yourself up for success are to, in whatever log management solution you're using, set up parsing rules to be able to extract structured fields from your logs. We saw in this example, we were looking at user IDs, page names, other kinds of structured fields that were embedded in the logs. And if you've set up some kind of parsing rule to extract that, it makes it a lot easier to do the kind of analysis and drill down that we were showing in that demo. So now we'll talk briefly about firefighting. And what do I mean by firefighting? Well, it's basically the same thing as troubleshooting. You're tracking down a problem, but when you're in a hurry, because it's a serious problem. Your site is down, or something really bad is going on, and you need some kind of resolution just as quickly as possible. And so, because speed is paramount in a firefighting situation, you want to be able to give yourself as much of a head start as possible. And so to do that in your preparation, you want to focus on the most common problems that you've observed in the past to occur on your site, or at least categories of problems. And once you've started to have the experience to identify typical patterns or types of problems that occur in your system, you can set up saved searches or dashboards where you have the queries defined in advance that are going to give you insight into that problem if it's happening again. And so just to illustrate that, imagine a few weeks have passed and we've gotten another report of performance problems again on our website. Well, I can go now to that troubleshooting dashboard, and immediately, without really having to think, I see some spikes on this graph. I say, well, what is that graph? Oh, invalid cache. And maybe I remember, or if I don't remember, I can just expand that and see what logs this is reporting on. And I can see, oh, this is that invalid cache issue. So whenever you track down a problem, if you throw the relevant signal onto a troubleshooting dashboard, then, we would be able to go and, your eye is very good at quickly scanning. We could have 50 graphs on here, and you can very quickly scan through this and see whether any of your usual suspects has reared its head. So, when you're setting yourself up for firefighting, again, anything that's come up as relevant in a past investigation is worth including on your troubleshooting dashboard, as well as critical parameters of each of the major services in your system, amount of traffic, error rates, things like that, to give you that. So if none of the specific signals that you've flagged in the past are jumping out at you, then at least you'll have these high level overview of your system health to guide you. Now let's talk briefly about load analysis. So load analysis is if you have a system with some kind of a capacity limit, and every system does, whether it's CPU, network, disk space. Systems always have limits on the amount of load they can handle, and you may want to analyze how that's being used. What's tying up your systems the most? Maybe for capacity planning, maybe because you're trying to optimize, or maybe because you're actually running out of capacity and you need to bring it back under control. And so there are many different kinds of resources that might be limited. It can be things like CPU and network. It can also be more subtle things, like the amount of space in some queuing system, or you may have software that's contending on an internal lock. Only one thread at a time can operate on that. That lock becomes a limited resource. But whatever your limiting resource is, whatever is limiting the system that you're trying to optimize, you want to start by finding log data that will measure that usage. Now, if your system is fairly simple and the workload that it processes is fairly homogeneous, then it may simply be that all you need to know might be just how many requests are coming into the system, because every request is going to use more or less the same amount of resources. But sometimes things can be very lumpy. You might, for example, have an image processing server, and sometimes it's given little thumbnails to process, and sometimes it's given a giant 50 megabyte or 50 megapixel photo. Those are going to have very different resource requirements, and if you're trying to analyze the system load, you're going to need to be able to distinguish those. And so then you'll need logs that record not just there was an access to the system, but this was the size or the cost or the processing time for each request. Then you can use the same kind of tools we've been talking about to break that down and see where see what's accounting for the bulk of the load on the system. Just to do a quick demo here, let's go back to this web server dashboard. And one of the graphs here is showing bandwidth, basically the amount of data that's coming out of this server. And let's say maybe we're having network issues, we're using too much bandwidth. So let's drill down into this bandwidth graph. Now I can look and see which URLs are being served by the site. I can see the home page is the most common. This is the page with the most requests. But that doesn't necessarily mean that this is the page that's using the most bandwidth, because it might be that some pages are larger or smaller than others. Now here we're graphing the actual amount of data being served in bytes per second, or actually megabytes per second. So let's break down the graph by that same URL field. And now we can see that actually there are two pages that jump head and shoulders above the rest, and they're both image display pages. So the home page, even though it was the most common page, most frequently accessed, is only accounting for the third largest amount of bandwidth, and it's really a distant third. It's the image pages that use most of the bandwidth, which makes sense because image files can be pretty large. But so this shows the importance when you're analyzing the load on your system of having log data that breaks down the size of different operations, because maybe that not all operations are created equal. Just to show another way of thinking about this, of coming at problems like this, I'm going to go to a saved search that I've set up in advance that's going to give information about the SQL database usage from this server. So we have some logs that are recording. We saw briefly earlier in one of the other investigations, some of the log messages coming out of this system are reporting on SQL queries that the application server is issuing. Here we're using a feature in Scalyr called Power Queries to do a little bit of analysis on that data. So we're, first of all, just literally searching for the word query, which will find those database query logs. We're doing a little bit of on-the-fly parsing to pull out the SQL query text from that, because it happens we hadn't set up a parsing rule for that in advance. So with Power Queries, we're able to do that on the fly. Then we're going to group those messages by the unique SQL query, and for each unique query, count the number of times it shows up, and add up the amount of time that was spent processing those. And finally, sort that in descending order by time. And that shows us that the largest amount of processing time is spent in this particular query. We can see some of the other queries that are using a lot of time. And this might give us a pointer to go, if our SQL server is a limiting factor, this would allow us to go back into our code and look for ways to optimize these particular queries. Maybe we can add an index or do something like that. Or maybe we can modify our code just not to use those queries as often. So things that you can do in advance to set yourself up for success with load analysis, obviously log the operations that your system is performing, and especially the expensive operations, the operations that are going to most contribute to bogging the system down. And this is an excellent place to use random sampling if the logs are otherwise too noisy or too voluminous. If you're logging just one operation in 10, that will still give you an excellent statistical picture for the kinds of questions we've been asking here, which operations occur the most frequently, what's their average size, and so forth. It's critical to log size or cost parameters, the information that will tell you which operations used the most resources. And also source parameters. What did we do and why did we do it? Which user or which upstream service triggered this? So that we'll be able to, when we see, oh, these are the large requests, we'll be able to understand, well, where did they come from, so that we can do something about it. And finally, it can be handy to throw some of those queries then onto a dashboard so that they're easy to discover, and you're not having to rebuild the query every time. And the last scenario that I'm going to talk about is forensics. And so forensics is when you're trying to do detailed analysis of some specific event. For example, you may have had a user report that they were using your system and something went wrong. They're a little vague on the details. It was yesterday afternoon. They're not quite sure when. They forget exactly what they clicked, but then something bad happened. And you need to be able to do anything about that. You need to go into the system and get much more precise. Exactly what happened. What did the user do that triggered the problem? Exactly what time did it occur? What went down in the code? So you're going to have to get down to, given that vague starting point, you're going to have to get down to, exactly the relevant log messages. The procedure is similar really to everything we've talked about, where you want to start by identifying a log message or a category of log that directly relates to the information you're starting with. So in this example, the information you're starting with might be, I know roughly the time period. The user said it was, Tuesday afternoon. And I know what user it is, so I know their user ID. Maybe I know their IP address. So what logs could we look at that would record an IP address or a user ID? Well, maybe it's your access log. So you go looking in your access log across the entire afternoon or the entire time period. You search for that user's IP address. Hopefully you'll find a few specific log messages from that IP, and now you know exactly what time the problem happened and exactly which server it was on. And then based on that, you can start to explore. For example, if the problem happened at exactly this moment on exactly this server, then you can search the surrounding logs from that server, or you can look at other operations from that IP address to see what else the user did in the chain of events that led to the problem. And some of the kind of pivoting operations that we saw when we were popping into Scalyr earlier, where you can select a piece of text and search other logs for that text, it might be an IP address, things like that can be helpful. And so that concludes my portion of the talk. I'll hand things back over to Dave.
Thanks, Steve. That was really informative, and hopefully you'll be able to stay around to answer a couple of questions that have come in. And with that, let me go into and share my screen to talk a little bit about sort of the emerging technology space. Ooh, wrong button. Sent. So one of the things that's real obvious is that when we control the applications and the logs that come into play here, it's possible for us to put the right sets of information. But as we move into a more services-oriented environment, it's becoming more and more important and more valid that we live and breathe by the information that comes out of those services. Be they a Kubernetes environment, be they a serverless environment, we're really dependent on the log information that comes from those players. So with that, we have to consider that each of these levels of extraction, each service adds another level of infrastructure to the monitoring concerns and to our forensics exercises and our firefighting exercises. So in short, to be honest about it, while abstractions make our life simpler, they make digging to be a lot harder inside of here. So it's turtles all the way down. Taking a look at this, for instance, with Kubernetes, while it's container orchestration, Kubernetes adds alone Kubernetes adds the capability from this for container orchestration. It adds a master node, which is basically responsible for the scheduler. It's responsible for the API servers that go out to here. It has worker nodes, previously known as minions, that actually are where the pods go inside of here. And each pod has its container. It can have the app. It can have multiple containers per pod, and it can contain what's called a sidecar, or a way that we can add something to every single implementation environment. So when we look at logs at this, we need to log at the various levels. So starting with the node level, we have to find these app logs, and the app logs are usually pushed through standard out or standard error. Different though, however, a container engine can redirect to somewhere. It doesn't always manage to be the same thing. When we have, for instance, a pod that's living, kubelets are a very dear friend inside of this here. They will keep one terminated container and logs alive. However, if the pod is evicted, the pod is completely killed, every log and every container goes away at the same point in time. Therefore, you need to make sure that you're capturing the logs coming through standard out and standard error to persistent storage if you want to see what happened when the log is no longer, or when the pod is no longer there. Your logs may not be there unless you've taken the extra step to be able to reserve those log informations. With system logs in the containers, the Kubernetes scheduler is kubeproxy. And when they're not in containers, kubelet, the container runtime, depending on the nature of your system you're running on, system D environments will log off to journal D. Otherwise, it goes into /var/log. So when we look at it at the cluster level, because Kubernetes is a cluster itself, there is no native Kubernetes solution. But you can push the logs directly from your application, and that can require a couple of different approaches here. Basically, you've got to have some way of, from that agent, pushing the logs to a centralized source. You can either run a node level agent on every node. You could have an API connection from your application environments. Generally speaking, we see it most common, particularly with large scale environments, that you use a sidecar that streams to standard out and standard error. Those sidecars are pushed with every instantiation of a new pod from Kubernetes. And they too can also run the logging agent inside of that. So those things give you that information and retain storage for all of your various pieces, no matter where they live, which is a big difference in today's services-oriented environment. Your services may live places that you don't know. And using another example here, Istio. Istio is a service mesh. It controls the services to service communication. Steve mentioned, for instance, that you do need to know how the communication between things happen, be it major subsystems within a monolithic application, be it a standard client server type of model. But in today's microservices environment, we're having more and more communications that live there. Istio is an open source project. It's got a tremendous amount of uptake here, but it's a layer that controls that communications across the network. It's transparent to the distributed apps. They see no differences inside of here. And because it's built in mind of this forensics and firefighting, it integrates into logging, it integrates into telemetry systems, and it understands policy around that. Under Istio, you'll hear two basic concepts, Envoy and Mixer. Envoy mediates the traffic. It gets deployed as a sidecar inside of here. Mixer enforces policy and access control. Of these, Envoy is the one that's most important to us. So Mixer. Mixer is the one that actually keeps track of the log instances. To track a new log stream in Istio, you need to add a YAML configuration for the log stream itself. Istio then will add that log stream to what it is sending out and collect it inside of here. Generally speaking, you'll find three pieces of Mixer that are important inside of here. It generates the instances for what Istio is looking at. It creates a handler to process these instances, and it dispatches those instances to handlers based on the rules you set up. All of this is information that you need to know when you're looking at pretty much when things have started and where things are working. In a services-oriented environment, understanding that is crucial to understanding what went wrong inside of this environment. Absolutely the easiest way is what's called Envoy access logging. You get a choice between structured with JSON or just straight text formats inside of here. And you can customize that format, something Steve mentioned early on, via what's called the access log format attribute inside of Istio. This allows you to pick and choose what you want and how you want it expressed. So, quick summary inside of here. We pay for ease of use with this additional complexity, but that complexity can add levels of abstraction to us here. These emerging technologies, as they get adopted, need attention just like your apps. Your apps are as dependent on those new technologies as they are on the basic code that you've written here. And finally, inside your logs is the truth about what went wrong, and always keep an eye on your logs. So with that, I'd like to open it up for questions. We have a couple that have come in here for Steve. And so let me do a real quick thing here. So first of all, Steve, can a single log entry ever be too large?
Well, never is a long time, so I'm going to say yes. But really, it depends on context. So, you may be, it depends on the, different systems where you might be feeding your logs may have different limits on what can. I think the tendency is, more often you're going to see a log has too little information than too much. Stack traces can get pretty large, and sometimes I've seen tools that have a little bit of trouble handling that. But really, the only things I've seen in practice that I would really call too large, or sometimes you'll see what amounts to some kind of complete database dump into a log. And I don't mean an entire database, but the entire set of data that's relevant to some operation. And sometimes it's tens of thousands of records. And that information might be helpful to record, but usually plunking it into your logging system that's not optimized in terms of how it displays and how it analyzes data, it's not optimized for that, is not going to be ideal. And so a technique we've used sometimes internally, and I actually alluded to briefly during the talk, is if you've got some big bolus of data and you want to record it, it might be useful for troubleshooting or some other kind of log-related scenario. Don't write it directly into the log, write it somewhere else, whether that's a temporary file on your server, if you have kind of persistent server instances, or into a database somewhere, or throw it into S3 or some other storage system like that, but throw it somewhere off to the side, and then in the log, make a record of where you put it, the temporary file name or the S3 object name, and so forth. And that kind of gives you the best of both worlds. It keeps the log structured to a size that's going to work well with logging tools, and at the same time, the data is there when you want to look for it.
Cool. The second question, you kind of alluded to this, but I think this person is asking for more clarification. I'm hearing a lot that the only way to go is structured logs. Do I really need structured logs?
Again, it depends on your tool. So, and it also depends on so people sometimes use structured logs as synonymous for JSON. Structure is a nice idea because it makes it easier for the machine to parse the data, but that doesn't need to be JSON. And so, I like that the key value style that we showed earlier, just conceptually pretty similar to JSON. You're basically just dispensing with the quotes and the colons and just sort of streamlining the syntax a little bit. And also taking a few fields that are going to be in every single message, like a timestamp, and saying we don't need a label for those. We just know the first thing on the line will always be a timestamp. And just using the key equal value structure for the variable things, the things that are in some log messages and not others. And I find that to be a great compromise because it is very parsable, but it doesn't have kind of the downsides of JSON of being bulkier and harder to read. So with that style, there's really not much cost to structuring. And so I find it to be a great compromise.
Cool. And we got one more that just came in here. So, this is a sort of a common one we hear a lot these days, but we have lots of things that are now being proposed here. So how do you contrast logs versus metrics versus traces?
So that, these things all complement one another. The nice thing about logs is they give you, I guess first let me discuss logs versus metrics. So logs will always give you more detail. A metric may tell you, let's say you throw a metric on the error rate of your service. You're recording that twice per minute. So the metric will tell you had 7 errors in a 30-second period. It won't tell you what the error was. It won't tell you which operation or page was being accessed when that error occurred. All it will tell you is there were some errors. It's throwing away a lot of information. You started with 7 individual failures, each of which had a bunch of details. You've thrown away all the details. You've even thrown away the identity of the 7 instances, and all you're left with is a number, 7. The upside of that, of course, is that a single number is much more compact than 7 complete log messages. And so the nice thing about metrics and the reason metrics have emerged over time as one of the components of an observability stack is that they're very compact and efficient. It's easy to store a metric or a time series. It's easy to visualize that, graph that, but it can't take you very far, can't give you detail. And so, I like to think about the trade-off of logs versus metrics as logs have strictly more information. They can do strictly more for you if you can afford to do it. In that affording might literally be dollars. You're, paying by the data size for a log management service. It might be, you're running an Elasticsearch cluster and it has a certain amount of capacity and not more. So you don't want to generate more logs than will fit in that cluster. But, in general, if the logs fit into what you can manage, then they will have more information than the metrics do. But you can't log everything. To take an extreme example, a classic metric is CPU utilization. Well, in theory, if you logged every instruction that your CPU executed, then you could just count the log messages and you wouldn't need a metric for CPU utilization. But of course, that's insane. It would be terabytes per second and you could never do it. So I guess the bigger and more significant the operation, the more likely you're going to want to log it rather than just throw away the detail and roll it up into a metric. And so then it's always a balancing act to find that dividing line. Traces and logs are actually very similar. A trace records an event that took place in your system. A log message records an event that took place in your system. So I actually think of traces as a specialized type of logs, where usually you'll have special instrumentation software that's generating those traces for you, whereas logs you're more likely to have coded yourself, scattering logging statements throughout your code. So tracing is a particular kind of event logging that's recording a very specific type of event with a very specific structure. And ideally, the ways you would work with it would be similar to the ways you work with logs, although the capabilities available in whatever particular tool you're using might vary. But traces are nice because they include the specific data to let you connect the dots across services. That's the tracing part. And so for the kinds of operations where that's relevant, tracing is very valuable. Then for the great mass of sort of other stuff, errors and little individual processing steps and things that aren't about connecting one service to another, that just is invisible to tracing. It's not part of the of what happens in a trace, and so that's where you're going to continue to use more conventional logging.
Cool. Thanks for the answers, Steve. And we have no more questions today. I'd like to thank everyone for attending the Scalyr Insight. Hopefully you've gained a deeper understanding and appreciation of what log files can do for you. And we look forward to seeing you next time on the next Scalyr Insights. Thanks so much.